Hello once again. On behalf of the BROSIS Foundation, I welcome you to another Learning Together session between Mrs. Dawes and myself. Mrs. Dawes teaching English and myself doing a little math. Our desire, our passion is to help you to have additional resources that can assist you as you improve your skills in English as well as in math. So last time we met, we were talking about the Pythagorean theorem and right triangles. Today we're going to go to another level. But I just want to take a little trek back into, how we have grown. If this was, say, for example, a soccer field, and this was, say, let's say 100 meters, and this was, say, 80 meters. And we found out that, okay, if Johnny walked from A to B, and then from B to C, and then while at C, he decided that he wanted to get back to A using the quickest path, we know that the shortest distance between 2 points is a straight line. So if he wanted to find out how far it is from A to C, back in the days before we knew the Pythagorean theorem, would have to measure this. We know that this is 100, this is 80. Would have to measure this, and then would know that distance. But as of last session, we discovered that we could actually calculate this number. Let's call this x. We could calculate x, assuming that this is 90 degrees, because we discovered that through Pythagorean, as a result of that theorem, we know that there is a relationship between the two legs of your right triangle, the two legs, and the long side, which is the longest side, which is called the hypotenuse. We know that this squared plus that squared is equal to the hypotenuse squared. So that's how we could calculate, instead of measuring, we could calculate the missing diagonal, okay? And you'd end up with 100 squared plus 80 squared equal to x squared. I should have chosen better numbers, but this gives me 1000. That's 10,000 plus 64,000 equal to x squared. And therefore we could end up with x squared equal to 16,400. And then therefore x, we know, would be equal to the square root. We have to get rid of the square by doing square root of 16,400. And we know that's coming with somewhere. Here's my calculator. I will take my calculator and find the square root of 16,400. And that works out to be approximately 128 meters. That's approximately 128 meters. So Johnny walked 180 meters going east, then going north. But then if you want to go straight home in the shortest way, taking that diagonal, it's only a total of 128 meters, okay? So that was the Pythagorean theorem. So now we want to see that there is actually more to calculation than just that. So let's go. Okay. Today, again, we're going to still be working with right triangles. All this work that we're doing, the Pythagorean theorem, has to do with right triangles. And today, we're also going to still be working with right triangles. Oh, one more thing we did last time is we also calculated the area of right triangles. Or if it wasn't a right triangle, we need to construct a perpendicular in order to determine the height of the triangle. And we discovered that the area is a half base times height. So if you were given something like this, you're given a right triangle, and if I said to you that this was, say, 40 degrees, and I told you, for example, this was, say, 24 meters. There is a principle that will allow us to find everything that is missing. Well, we know this, we can find this, we can find this, we can find that, and we can also find the area. With the Pythagorean theorem, we need to have two sides to find the third. This principle that we're going to go into is a method that we can use where if we have a right triangle and one of the acute angles with one side, we can find the other two sides. So there are principles that associate the sides of the triangle with the angles. Again, it's relationship between the angles of a triangle, a right triangle, and the sides of the triangle. So that's where we're going, and that's what's going to take us into what is called the trigonometric ratios. A ratio is something compared to something. So I'm just trying to give you a preview as to what this entails. Again, what do we need? We need a right triangle, okay? And with the right triangle, we must have at least one side, or if we don't have one side, we must have two sides along with the right triangle. And with that, we can solve everything else. So we need one angle different from the 90-degree angle along with one side, or a right triangle with two sides, and we can find all the other pieces of information for the triangle. Isn't that cool? So let's talk about the ratios so that we can make the connection. Here we go. Okay, so that's a right triangle. If we're given an angle, let's call this x. The sides of the triangle have names. One name is constant, it never changes. And that's the side that's across from the 90 degree. So this, as a name, it's called the hypotenuse. So the side across from the 90-degree angle, and it's always the longest side. Remember, if it's a right triangle, all three angles make 180 degrees. So if this is 90, then these two must make 90 degrees. They are called complementary angle. That's for a different conversation. So this side here has a name, and this side here has a name. The names are dependent on which angle you're using. If you're using this angle, it has a name. But if you're using this angle, it has a different name. So these two names are dependent on which angle you're working with. Notice, we're not talking about the 90-degree angle. We're talking about one of the acute angles. Remember, we call these legs, but they have special names. So the one that is beside your angle is called the adjacent. And the one that is across across your angle, across from your angle is called the opposite. So this is the adjacent, this is the opposite. These names are dependent on which angle you're dealing with, because if you're dealing with angle Y, then this would be opposite. And this would be adjacent, because this is beside your angle, but this is across from your angle, opposite. And I always use the example of a street. If this is a street, you have houses here. Okay? Then the house that is beside you is adjacent, it's beside. The house that is across the street from you, across, is opposite. So if you are across, you're opposite. If you are beside it, you are adjacent. So that's how you can tell the two names. You'll be surprised to know how many students I've had over the years who get confused with the adjacent and opposite. It's really an English word. You know, beside is adjacent. Opposite is across from. If we're sitting around a table, the person sitting across from me is the person sitting opposite to me. The person sitting beside me is the person that's adjacent to me. It's not complicated, but some people have difficulty remembering that. So we will not have that difficulty. Okay, so we'll use the letter H for hypotenuse, the letter A for adjacent, and we'll conveniently use the letter O for opposite. So those are the three names, and now I'm going to give you the ratios, okay? The three, as a matter of fact, I'm going to erase this. Okay, here we go. So there are 6 okay, I'm going to use the word trig, the abbreviation trig for trigonometry. So whenever you hear someone say we're going to do trig, we're doing trigonometry, okay? So there are 6 trig ratios. You have sine, cosine, tangent. Okay? Then you have the reciprocal, that is 1 over sine is cosecant. So 1 over sine is cosecant. 1 over cosine is secant. And 1 over tangent is cotangent. So these are the reciprocal functions. So these are the ones that are important. And then later on, you're going to be using the reciprocals, which will be the other 3. That makes it a total of 6. So these are the original functions, okay? Now, we have abbreviations for these functions. I'm laying the foundation. So you will see something like this. Sine of x is always of an angle, is a function with an angle. Sine by itself is meaningless. It has to be sine of an angle, like square root of a number. Sine of an angle. Cosine, that's the abbreviation. Tangent, T-A-N. So for sine, we use S-I-N. For cosine, we use C-O-S, cos. And for tangent, we use tan. Okay? For cosecant, we use C-S-C of x. For secant, we use S-E-C of x. And for cotangent, we use C-O-T of x. So those are the 6 functions. Sine, cosine, tangent, cosecant, secant, cotangent. Okay? Again, you're not going to be spending a lot of time on these. These are the ones we're going to spend time on. Okay. All right. Let's go and look at how they're defined. Okay. So given if this is x, this is the opposite, this is the hypotenuse, this is the adjacent. We already discussed opposite, hypotenuse, and adjacent. Well, sine of x is always equal to opposite over hypotenuse. So whatever this measurement is, that number over this number is the value of sine of the angle. So that's the ratio you're getting for sine. Cosine of x is the adjacent over the hypotenuse. So it is A over H. And finally, tangent of x is equal to opposite over adjacent. So it is O over A. So you're going to say to me, but how can I remember these things? It's so confusing. It's so much to remember. And I will say to you that there is what is called a mnemonic, or something to assist your memory that many people use and have found it to be very helpful. And that is SOHCAHTOA. Now, you can't afford to be cute when doing this. You have to be able to express yourself. You say so-ka-tor. So-ka-tor. That's what we use to remember the ratios. So-ka-tor. So-ka-tor. So, sine is opposite over hypotenuse. Ka, cosine is adjacent over hypotenuse. Tor, tan is opposite over adjacent. Those are they right there. If you can remember that, it will be very helpful. So instead of trying to remember sine is opposite over hypotenuse, da 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 da. Just remember this mnemonic. Okay, here's the word. All this is something that helps you to remember things. It's almost like an acronym. Okay? So-called TOR is what we use to help us to remember. Okay? To assist memory. It's a memory aid. Good. Now, we did discuss that cosecant is 1 over sine. So therefore, you could write cosecant of x would actually be equal to h over O. So once you know sine, just flip it, and that's cosecant. Once you know cosine, you flip it, and of course, once you know tangent, then we have cotangent of x is going to be equal to a over O. So you really don't need to memorize these. All you need to do is to know this, because from this you can find that. From this you can find that. From this you can find that. Just flip and it's over. So now that we have defined the trigonometric ratios, let's try and use them now in a question. Okay, so we're going to start with a simple exercise. So we have two sides of a right triangle. So the first thing we need to do is to find the missing side. So let's call it P. And let's call it M. Well, 6 squared plus 8 squared is equal to M squared. It's a right triangle, so we know we can use Pythagorean theorem to find the missing side. We have two sides. We can use Pythagorean theorem to find the side that's missing. And 6 squared is 36. 8 squared is 64. Equal to M squared. So we realize that M squared is equal to 100. So therefore, M has to be 10. So we could put that side is 10. So now we are ready to answer the questions. This is X. Sine of X is opposite. It's opposite over hypotenuse. And in this case, the opposite is 8, the hypotenuse is 10. So it is 8 over 10, which happens to be 4 over 5. We can simplify it to 4 over 5. So that's the answer for that. What about cosine of X? That's adjacent over hypotenuse. Cosine is CAH, so CAH. CAH, C-A-H, cosine is adjacent over hypotenuse. So therefore the adjacent is 6, the hypotenuse is 10. So we could write it's adjacent over hypotenuse equal to 6 over 10 equal to 3 over 5. And finally, tan of X is TOR, so CAH TOR, opposite over adjacent. The opposite is 8, the adjacent is 6. So tan of X is opposite over adjacent equal to 8 over 6 equal to 4 over 3. And now we go to the other one. Sine of Y. Y is here. So sine is opposite over hypotenuse. So sine of y is 6 over 10, which happens to be 3 over 10. Cosine of y is adjacent over hypotenuse. So it's 8 over 10 equal to 4 over 5. And finally, tan of y is opposite over adjacent. So it's 6 over 8, which is equal to 3 over 4. Okay? So now that's your first question introducing you to the trigonometric functions and how we could apply them, trigonometric ratios, and how we could apply them to a given right triangle. Let's try another one. Okay, this time I'm going to do it in the form of a question, a practical question. Okay, so that's a mouthful. Here is a ladder, it's 30 feet long, and it's resting against a building. Of course, it has to make an angle with the ground, and it's making an angle of 60 degrees with the ground. So here's the ladder against the building, making an angle of 60 degrees with the ground. And your job is to find how far is the base of the ladder from the building and how high up is the ladder against the wall of the building. Okay? So we're clear on the details now. Okay? So the best thing to do to get an idea how to solve this is to sketch a building. And of course, this is the ground, and here is the ladder. It makes an angle of 60 degrees, and this is 30 feet. And of course, you assume that the building is vertical and the ground is horizontal, so it makes an angle of 90 degrees. So let's call this portion here, we need to calculate from here to here. Let's call that X. And we need to know how high up is it. So let's call this H. So we have one side of the triangle, and we also have one angle, and we need two lengths. So looking at the angle with 60 degrees, what are the names of the sides of the triangle, and which sides are they? Well, this one is across from the 90 degrees, so this is the hypotenuse. This is your angle, so therefore x is your adjacent. X is your adjacent. And then this is opposite, your angle, so h is your opposite. So you could write this equation and then solve it. You could write the equation and solve it. You could say cosine, if we're trying to find x, cosine of 60 degrees is equal to adjacent over hypotenuse is equal to x over 30. And of course, it's over 30 feet. It is x over 30 feet. And we need to get x by itself. So we need to get rid of the 30 feet from the denominator. So we need to multiply both sides by 30 feet. So therefore, x is equal to 30 feet times cosine of 60 degrees. Now, in your calculator, you will see sine, cosine, and tangent. Those buttons are on your calculator. So you might already know, or you might not know, that cosine of 60 is a half. But if you didn't know that, you could turn on your calculator and press cosine of 60 and press enter, and you see 0.5. So therefore, x is equal to 30 feet times 0.5 equal to 15 feet. So this is 15 feet from the base. So yeah, this is 30, this is 15. You could find the missing side by using the Pythagorean theorem, because you now have two sides of a right triangle. So why not? Let's find it using trigonometry, and then later on, let's go back in and use the Pythagorean theorem and see if we have the same answer. How about that? Okay, so trigonometry. This is the opposite, this is the hypotenuse. So sine of 60 degrees, sine is opposite, S-O-H, so ka, tor, opposite over hypotenuse. So it's equal to h over 30. So it's the same dance, multiply both sides by 30 feet, and that gives us h, which means that h equal to 30 feet sine 60 degrees. And that's going to be equal to sine of 60 is like 0.8667. Okay, it's not an easy one like cosine of 60. So it's going to be sine of 60 equal to 0.866. So it's going to be 30 feet times 0.866. I'm going to go ahead and multiply by 30. And the answer is 25.98, approximately 25.98 feet. So we got the distance from the base is 15 feet, and the height of the building, so it could be a window that you're trying to get into, is 25.98 feet. Okay? And now the question is, if I had used Pythagorean theorem, would I have gotten the same answer of 25.98? And my response is, let's try and see. So what do we have? We have this shape. 30, 60, 15, and 8. So it's a right triangle. This is, the ladder is 30 feet. This is your ladder. This is the building. This is the ground. Okay, the Pythagorean theorem says, well, these are the legs, and this is the hypotenuse. So h squared plus 15 squared is equal to 30. By the way, we're just checking to see if it works. I already think we already know what it should be, so let's see if it's consistent. Okay, so h squared plus 225 15 squared 225, 30 squared 900. No, nothing out of the ordinary. Get h squared by itself. H squared equal to, we subtract 225 from both sides. Nothing greater than 675. So far, so good. And therefore, h has to be equal to the square root of 675. Now, I think I know that 25 squared is equal to 625. So 675 has to be more than 25, okay? So let's see. We need to find the square root of 675. Here we go. Second, 675. Enter. I get 25.98. Which is exactly what we had before. So it's beautiful when the math is consistent. You do it one way, you get one answer. You do it a different way, and if it is mathematically correct, the two answers must be the same. If they're not the same, something is wrong with one of the methods, or both methods are wrong. Okay? So let's see if we could look at some more examples. Okay, so find or missing information. Well, the first thing that is necessary, or that's easy to find, is triangle has three angles. This is 90, this is 30. So we know that this has to be 60. Okay? Let's go and try and find x. This is 30 degrees. We have one side, so we can't use the Pythagorean theorem because we only have one side. I don't need my glasses. Okay, we just have one side. So we can say, okay, from this angle, we know this is the hypotenuse. How do I know? Because it's across from the 90 degrees. So this is 30 degrees, so this is the opposite. And the y is the adjacent when you're focusing on the 30. So that's the hypotenuse, that's the opposite. And that's your adjacent. Okay? So here we go. Sine, let's use a different color, just for the contrast. So sine of 30 degrees has to be equal to 14 over x. Opposite over hypotenuse. X is labeled as the hypotenuse, so we need to find what x is. So check this out. Your x is on the denominator, but we need to get x on top. So we cross, this by itself is just sine 30 over 1. So we could cross multiply, and we end up with x sine 30 is equal to 14. And now to get x by itself, we need to get rid of the sine 30 degrees. So we divide both sides by sine 30. So this cancels this. So x is equal to 14 divided by sine 30. I know that sine 30 is a half, but you wouldn't know that. So you take your calculator, you clear, you type in 14, and you press divided by, and then you do sine of 30, and you should get 28. Press equal, and the answer is 28, because 14 divided by a half is 28. So we now have x, and we have 14. We need to find y. Again, you can use the Pythagorean theorem, or you could go ahead and use cosine, because for 30 degrees, this is your adjacent, and this is your tangent. Oh, no, we can use tangent. We haven't used tangent yet. So maybe it's a good one. So this is opposite, and this is adjacent. So tan 30 degrees is equal to 14 over y. Opposite over adjacent, 14 over y. So y tan 30 is equal to 14. So y is going to be equal to 14 divided by tan 30 degrees. And that's approximately equal to, again, we go to the calculator, and we clear, and do 14 divided by tangent of 30 degrees. And the answer is approximately 24.25. Approximately 24.25. So the question is, of course, we realize that the hypotenuse is 28, this is 14, and this is not the hypotenuse, it is less than 28, so that's a good sign. But suppose we didn't know how to use tangent. Let's check to see if we could have used Pythagorean theorem and if it would be the same answer. So here we go. 14 squared plus y squared is equal to x, which we found out to be 28. So 14 squared is 196 plus y squared equal to 28 squared. I do not know what that is. 28 squared is 28 times 28, and that's equal to 784. So now I need to take 196 from 784. We end up with y squared equal to 588. Okay, so therefore y has to be equal to the square root of 588, which is approximately equal to, and then I just take my calculator and I do second, and then the square root 588. 588, and my answer is 24.25. Again, didn't have to, but I just thought it would be neat to show us that we still could find the answer without using tangent. Okay? Okay, so let's look at a practical question now. Okay, so John saw a bird, and the bird at an angle of elevation of 28 degrees, angle of elevation. So this is the bird. Okay. And the question, John is 6 feet tall. Okay. And if the bird is, from John's vision, if the bird is 200 meters away, how high is the bird from the ground? How high is the bird height from how high is the bird from the ground? Well, remember the angle of elevation is from Johnny so the elevation is up. How much you have to look up to see. Angle of depression is here. So you might hear those two terms. Let me write them so you can see them. When you're up looking down, it's called the angle when you're down looking up, it's called the angle of elevation. So you can say up is to elevate, down is to depress. Words, up, elevate, down, depress. So let's elevate, let's look up. Okay, so question is, how high is the bird from the ground? 200 meters, 90-degree angle. So do you agree that we could find this distance? We could find that height and then add the 6 feet to that number to get the total height. Okay, so here goes. If this is 28 degrees, this is a 90-degree angle, so this has to be the hypotenuse. What is the name of this side here? Relative to this angle. This side has to be the opposite. Okay? So we could call this unknown, we don't know what it is, let's call it x. So x plus 6 will give you the height h. So here we go. Which function, which trigonometric ratio deals with opposite and hypotenuse? Is it tangent, TOA, opposite and adjacent? No. Is it cosine, CA, adjacent over hypotenuse? No. Is it sine, So opposite over hypotenuse. Yes, it is. So you could write sine 28 degrees is equal to x over 200. Oh, I'm using two different measurements. Not good. So let's change this to 2 meters. 2 meters. So we can be consistent. That's what happens when you write questions on the fly. This is 2. Okay. So to get x by itself, we multiply both sides by 200 meters. So therefore, x is equal to 200 meters times sine of 28 degrees. And that's approximately equal to, clear, 200 times sine of 28 equal to 93.89. 93.8. So the height from Johnny's eye level to the bird is 93.89 meters. Johnny's 2 meters above the ground. So therefore the total height is going to be equal to 93.89 plus equal to 95.89 meters. And that would be the height of the bird from the ground. I think we have one more question that we could work on. Let's see. Let's try this one. This might be a little tricky. This might be a little tricky. Okay. Okay, here we go. Okay. If from Mark to Paul is, say, 60 meters. From Paul to Susan is, say, 100 meters. And the angle between Paul, Susan, and the riverbank is, say, 40 degrees. And the angle between Paul and Mark is, say, 50 degrees. How far is Mark from Susan? how far are they apart? So let's go again, let's check and see what we have. From Paul to Mark is 60 meters. From Paul to Susan is 100 meters. The angle between Paul, Susan, and Mark is 40 degrees. The angle between Paul, Mark, and Susan is 50 degrees. How far is Mark from Susan? So we are the problem solvers. So how do we do that? Well, first thing first, we do not have. This is too easy. This is going to give you 50 plus 40 is 90. So this means that this is 90. I don't want it to be 90. So I'm going to play with the numbers. Let's call this 60. I don't want to make it easy. I want to make it a little bit more work. So this is 60, this is 40. So this is going to be 80 degrees. So it's not a right triangle. So how about if we drop a perpendicular from here? So that's a right angle right here. And of course, this is going to be a right angle on the other side. So now we have two triangles. If I can find this, x1, and then this, x2. If I can find this length, and then I can find that length, add them together to give me the total distance. Make sense? Okay, so if this is 60 and this is 60 degrees, what is x2? Well, what is the name of this side and what is the name of this side? This is 90 degrees, so this is the hypotenuse. This is x2 and this is the angle, so this is the adjacent. So cosine 60 degrees is equal to x2 over 60 meters. So multiply both sides by 60 meters, we end up with 60 meters times cosine 60 degrees is equal to x2. So therefore, x2 is equal to cosine of 60 is a half. I know that. You can check it on the calculator. A half times 60 meters gives us 30 meters. So we already have part of the puzzle solved. From here to here is 30 meters. So now we need to find x1. Again, it's the same principle. Here is your angle. Here is your 90 degrees. So this is your hypotenuse. And this has to be your adjacent. So cosine 40 degrees is equal to x1 over 100 meters. So therefore, multiply both sides by 100 meters, we end up with x1 equal to 100 meters times the cosine of 40 degrees. And that's approximately equal to, I do not know the cosine of 40, so I go to my calculator. I clear. I do 100 times cosine 40 degrees. And that gives me 76, approximately 76.6 meters. As you can see, if this part is x2 and this part is x1, then the entire thing has to be x1 plus x2. So the total distance x is going to be equal to x1 plus x2 equal to 76.6 meters plus 30 meters. And that works out to be 30, and that gives me 106.6 meters. So again, we were not given a right triangle, but to execute our job properly, we broke up our information and created two right triangles, and then we were able to apply the trigonometric ratios. Well, in this case, it was cosine ratio, which is adjacent over hypotenuse. We did it twice because it's two different triangles, and then we add the two pieces together. Boom. Oftentimes, we might not have a direct route. We're going from one location to another. Sometimes we have to take a detour in order to get to our destination. It's really part of life. Not every path is a straight path to our destination. Sometimes we are forced, and sometimes by choice, we might have to take a detour, but ultimately, we keep our eyes on our destination so we can get there. So it is with this case, we knew what we wanted to find, but there wasn't a direct way to get there. We had to get there indirectly, but ultimately, we arrived at our destination. We achieved our objective, and we delivered. So today, I've introduced you to the trigonometric functions, and the most popular ones are sine, cosine, and tangent. I also mentioned that the trigonometric ratios are associated with right triangles. I also mentioned that their reciprocals are cosecant for sine, secant for cosine, and cotangent for tangent. I also give you the mnemonic, so, ka, tor, as a way of remembering the trigonometric ratios, where so is SOH, sine is opposite over hypotenuse. Ka is CAH, which is cosine is adjacent over hypotenuse, and tor is tangent is opposite over adjacent. I hope this was helpful, and I hope this will help as we build our foundation and build our toolbox as we progress. I promise you that there will be more questions that will incorporate what we have already covered. Next class, next session, we're going to be covering how to find the area of a triangle that is not a right triangle. Very interesting. A triangle, the area of a triangle that is not a right triangle, which means that we might not be able to use a half base times height. Okay? And then I'll also introduce you to the law of sines. So next class, we'll do the area of a triangle that's not a right triangle, and also the law of sines, followed by next week, we'll do the law of cosines. A little bit more advanced, but still staying in check with normal function processing. Thank you so much for joining us, and on behalf of the BROSIS Foundation, we thank you for learning together with us, and we ask you to tell a friend and invite a friend. Enjoy the rest of your day. Thank you.